Okay, so thanks for coming, everyone. Today we are going to be going over MongoDB, Mongoose, and just databases in general. So before we jump into that, what is a database, right? Why do we need them? Um, Most useful applications will have some sort of database because it lets them store data, right? You can almost think of a database as like your computer's hard drive, right? It lets us say, hey, I want to make sure I can store this data and that I can always access it. If I, do something on, like, let's say Instagram, for example, I make a post. I want to make sure I'm storing that post so that if I come back to Instagram, that post will still be there. Okay? All of our projects at Hack for Impact are backed by a database, and in recent years, all the projects have used Mongoose or MongoDB. Okay. Any questions about that quick overview of what a database is, why we need it? Okay, cool. So you may have heard of MongoDB before. DB standing for database. Whoa. Mongo is essentially a like brand of database. And it's also, there's a company behind Mongo that's like a provider of database. So they'll like host your database for you. It's the most popular database provider for something called NoSQL. And without worrying too much about the details of what that means, when you hear like NoSQL or NoSQL, that means that you can put anything in that database. Text, numbers, you can even put like arrays and JavaScript object or TypeScript objects, excuse me. So you can literally store anything in a Mongo database. Okay. So before we actually jump in and look at MongoDB and Mongoose, we'll need to understand a few MongoDB concepts. So we'll go ahead and open up a database now and take a look. And don't worry about following along here, just pay attention. So to open, I don't actually have it open, but to open a database, I'm going to type in MongoDB Compass. If you followed the onboarding, you'll already have this installed when you installed Mongo. And then I have this local database running, so I'm going to go ahead and connect to that. And I'm actually going to zoom in so you guys can see a little bit better here. Whoa, how's that? Can you guys all see pretty good? Okay. I lost my notes here. Okay. So this is an application called MongoDB Compass. You should already have it. The first thing that I want to draw your attention to is this sidebar here. And specifically underneath this field that says filter your data, you'll see a list of something here. And this is actually a list of the databases that we can access. Okay. The first three, admin, config, and local, those are used by MongoDB itself to kind of manage and configure our database. The last one, this test one here, this is the one that our applications actually connect to. They're where we store our data for the application. Okay. And so as we go through the basics and learn some of these concepts, we'll pretend that we're improving on the to-do application we made last week by backing it with a database. So did you notice last week when I would refresh the page, all the items I wrote would go away? The database would help us say, hey, keep these items here. Don't let them go away. In order to accomplish this, we first need to figure out how to group our data. And by this, I mean, in order to figure out how we can make our to-do item, our to-do list app have a database with it. And in order to effectively group our data in Mongo, we use something called a collection, okay? A collection is essentially a big array of similar data, right? So in this example, if I click on this test database here, we can see I have a collection called to-do items. And that stores, as you could probably guess, all of our to-do items. In this example that we're going through here, we only have one collection in our database, but you might imagine that we could have a few different collections here. Maybe we want to allow different users to have different to-do items and let people log in. In that case, we would have a users collection where we would store the information about our users. Or maybe we would want to allow you to create different to-do lists. So maybe I would want like a to-do list for bedtime or a to-do list for like homework. We could create another collection in here that's called to-do lists that stores information about those different to-do lists. Okay. So the main idea here is that being able to group your data like your similar data is super powerful, right? And so now that we know how to actually group our data together, we need to actually put some data in the database. So let's go ahead and click on this to-do items collection here. And when I do that, you will see that we already have a bunch of data in our database. Each individual piece of data in a Mongo database is called a document. So this is a document, this is a document, and this is a document. Okay? You can think of a document as a TypeScript object, right? So you remember we learned about how TypeScript has these objects where you can group similar data together in TypeScript. Mongo has a similar thing. Each document is like a single TypeScript object, right? They all have property names. So here you see we have a name property, and then the value of that is do the dishes. Then we have a description property. The name of that is unload and load, or the value of that is unload and load. And you can see it looks pretty much identical to the interface that we defined last week when we were looking at the TypeScript example. You remember we had the to-do item interface that had a name that was a string and a description that was a string. We have the same thing here, right? The only difference is that we have this weird extra field right here called _ID. You may have been able to guess what this is for, but this is a unique identifier for our data. So you could imagine maybe we have two to-do items that don't have a description, or they do have a description, and the name is exactly the same and the description is exactly the same. How can we tell those apart, right? If we didn't have this ID field, we wouldn't be able to tell those apart. Those would look exactly the same in our database. But thanks to this ID field, we can have two to-do items with the same name, same description, and I can still tell that those are different to-do items. Does that make sense? Okay. So that's really it. Those are the two biggest concepts you need to know for MongoDB. And now that you know that, you can understand some of the stuff we'll go into and how we effectively work with the database in our applications. Any questions so far? Awesome. Sweet. So this is all good, but there is a bit of a problem with just MongoDB on itself. You may remember that I said MongoDB is a NoSQL database, so we can put anything into it. So there's nothing stopping me from maybe deleting a random field or adding an extra field into a document. So for example here, I can go ahead and change this name field to be like title. Like maybe one place in my application accidentally says create a to-do item, but instead of having the name be called name, it's called title, right? And then I can just update that. That's all good. So now if my application is expecting a to-do item to come back from the database with a name field and a description field, and it displays the name, it's not going to know what to show for this to-do item right here, right? Because it doesn't have a name field, it only has a title. Okay? So because of this issue, at Hack for Impact, we interact with MongoDB through something called Mongoose. Mongoose is something you can install. It's what's called a library, so we can use their code, something you install, and it's essentially a wrapper around MongoDB. And by wrapper, I just mean that it has all the same functional as MongoDB with a little extra stuff on top, right? It wraps MongoDB and adds some extra functionality. So for the rest of the lesson, I will be working out of the Web Dev Workshop SP24 repo, and I'll be in the 4 folder. If you're watching at home, feel free to follow along. Okay, so the first step to actually working with Mongoose in order to interact with a database is to define something called a schema. A lot of definitions today. A schema is essentially a TypeScript interface, but for our Mongo collection, right? It defines the structure of the collection. So let's go ahead and take a look at like what this means and how we can actually make a schema by building a simple database for a Twitter-like application where we'll have users and users can post tweets, okay? First, we will go into this models folder and we will create a new file called tweet.ts. And then in this file, we're going to do a couple things. First, we're going to define a variable called a constant variable called tweet schema. We're defining a schema for a tweet. This is what a tweet will look like. And then in order to actually make this, Mongoose provides a class called schema. So we'll create an instance of that class with new schema, and then I'll hit enter to automatically import that. And then inside of this new schema, parentheses, I will actually create an object. And then inside of this object, I will go ahead and start defining how how a tweet is going to look. Okay. So in order to do that, it's kind of similar to how we define interfaces in TypeScript. I'll say the field or the name of the property we want to define. So text, we'll assume that our tweet has like a text property, and that will contain the actual content of the tweet. And then I will use text is going to be an object, and inside of this object, this is where we're going to define some of our properties about the property. That's bad. Where we're going to define some of the characteristics about this property, right? So for example, what type should text be? Well, the type is going to be a string. Okay. Also, every single tweet needs to have this text property because every single tweet needs to have some content, right? So we'll go ahead and also make this required by passing required true. Okay. So as a quick recap of just what's going on right here, first we're saying, hey, I want to make a new schema called tweet schema that's going to define what a tweet looks like in our Mongo database. Every single tweet is going to have a property called text. That text is going to be, what the heck is going on? Oh, I have caps lock on. That text is going to be a string, and it's going to be required. So we need to have, each tweet needs to have a text property in the database. Okay. The next thing I'll do is I will go ahead and create a TypeScript interface for a tweet. So I'll say export interface, and this one I'm going to call iTweet. I don't really like this pattern. This is like a Java pattern where you say like I something to specify that it's an interface. You don't really do that in TypeScript, but we're going to call something else tweet, so we have to do it. And inside this interface, we're going to define, like we've done before, what the tweet object should look like in our TypeScript code, right? So we'll do text : string, and that's it. And as you can see, the same information in the Mongoose schema is encoded in this TypeScript interface, right? So you can see we have the property called text. It should be a string, and that's defined up here. We say we have a property called text. It should be a string. And then since we don't have this question mark here, that's implicitly saying that this property is required. And we're explicitly defining that up here where we say required true. So you can see how very similar this is. One's building our definition for TypeScript, and one's building it for MongoDB. Then finally, we are going to create a type for our actual document. So if you remember, a document represents a specific piece of data in our database. We're going to create a type for that in TypeScript so that when we get data back from our queries, when we get data back from the database, we can actually have a type to specify or tell us what that's going to be, right? So I'll say export interface tweet document, and then I'm going to do something weird here, extends document, and I'm going to import that from Mongoose, and iTweet. Okay, and a quick aside about what this is doing. This is saying the tweet document interface is going to have all of the properties that a document has, and it's also going to have all of the properties that iTweet has. So it's going to have text, and then it's also going to have a bunch of other stuff that Mongoose goes ahead and puts in there for us so that we can interact with the data a little bit easier. Okay. Again, so how's this feeling? Any questions? What's up, Andy?
So the extends document, that's from Mongoose?
Extends, so the question is the extends document from Mongoose? Extends is a keyword in TypeScript, so it lets you say, I'm going to create a new interface, and it should have all of the fields of this other interface plus some extra ones if I want. The part that comes from Mongoose is this document type or interface here, and we can look at it. It's going to be really confusing, but this is what that type is. So we're saying it should have all of that stuff as well as the stuff from the tweet. Does that answer your question?
Yeah.
Okay. Any other questions? Is this all sinking in? Kind of? Okay. If you have any questions, just let me know. If anything's confusing or you want me to re-go over anything, that's fine. Just ask. Okay, cool. So now I'm going to go ahead and copy and paste some code from my notes here that will make this schema usable by creating something called a model from it. I know, another definition. We're almost over, done with definitions. But I'll go ahead and copy this code here, and I'm going to paste it in. And then I'll do my, I'll hover over this, do the quick fix, add all missing imports, and save that. Sweet. Okay, so I actually do want to take a quick aside to briefly touch on models. You may have noticed that when we created this TypeScript file here, we put it in a folder called models, and then we also just went ahead and made something called a model. What is a model? A model is a variable that represents our actual collection in Mongoose, okay? A nice analogy that I like to use to think about the difference between a schema and a model is a schema is like a blueprint, right? It defines a blueprint for a building. It defines the overall structure, the layout of the rooms, all that stuff that you need to know before you build an actual building. A model is like the actual building itself, right? So it has all of the stuff in it that was defined by the blueprint. So bringing this back to the schema versus models, our schema is going to define how our collection should look, and then our model is going to represent that actual collection. Does that make sense? That's a little bit confusing to grasp. So if you have any questions or you just want to rehash that back to me, that's fine.
Could you explain in TypeScript terms, like you had the object analogy? Is there like an analogy?
Yeah, so here's an analogy you might be familiar with from your Java class. You remember you have a class, right? You define a class with the like, I don't remember the syntax, but it's like class, whatever, and then you put stuff in here, right? You might define a variable like here, like this. I'm saying this class is going to have a variable on it. This is just the definition for a class. Then when you want to use that class, you would do something like var t whatever equals new whatever. So you're actually creating an instance of the class here, right? A similar thing is going on with Mongoose in the schema versus model. The schema is like your class definition. You're telling Mongo what the collection should look like. And then your model is like when you create a variable from that class definition. Does that clear things up? Does that make it a little bit easier to understand? Okay. Any other questions about model versus schema or anything like that? Okay. You don't have to worry too much about like what this line of code is doing here. I've always just copy and pasted it from other repositories that have been worked on in the past and then just changed the stuff I needed to, and that's worked fine. But awesome. Okay. So now when we actually want to interact with our database, so let's say I wanted to create a new tweet in our database, we would use this model to say, create a new tweet in the database, right? And we'll take a look at that in a second. But before we move on, I want to talk about another vital concept for using databases in real-world applications, being able to reference other data in databases, right? So let's say, for example, that I want all tweets to have an author, right? I want to know who wrote a tweet. And these authors should be actual users in our database. They shouldn't just be, you know, an arbitrary string representing like a username for a user in our database. It should actually reference another user in our database. So we can do this in Mongoose. And to do this, I will go ahead and quickly create another schema and model for a user. And I'm actually, again, going to just copy and paste. The same stuff is going on in this one that we already talked about. I'm just defining our user to have a username, an email, and then an optional first name and last name. Then I define our TypeScript interface, document, and model for all that. Okay. Okay. So now that we have a model for our users, we need to tell Mongoose that we want a tweet to have a property called author that actually references this user model. Okay. So to do that, I'll come in here in our schema and I'll define a new property. I'll say, okay, a tweet should also have an author, right? The type here is going to be a little bit weird. It's going to be the schema.types.object_id. What is this saying? You may have noticed when we went over MongoDB that this ID is this weird object ID thing. Essentially what this is it's saying this is an ID and we have a special class for it, right? So the schema.types.object_id is just saying the type of this field is going to be an ID, right? It's going to be an ID referencing another collection, right? But how does Mongoose know which collection this ID is going to reference? For that, we have a special field we can put in here called ref. And then the value for this property is going to be the name of the model we want to reference. So in this case, I want to reference the user. And what this is doing is it's saying, okay, the author field, the author property is going to have an ID in it. That ID is referencing the ID of a user, right? So like in here, we have this ID. The user will also have an underscore ID. The ref is saying, okay, when you have this field, if you want to know what user that actually is, you're going to look in the users collection for a user with that ID, and then you're going to return that, okay? And then again, I'll make this required. Any questions about references and like the purpose of them or why we need them or what this code means right here? Hayden.
So anytime anyone creates a tweet that in the way you have it currently set up, is it going to, I guess I'm confused on how it's actually differentiating the user. How does it know who's doing what? Like, how does it, like, I know the program is like a skeleton vest, but now it's still, you know what I mean?
So is your question about how, so I just want to make sure I understand your question. Is your question about like how it knows when it's stored in the database, or
How does it differentiate between me calling tweet and my calling tweet? Is it just based on machine or is it?
Gotcha. So that's an implementation detail of like the actual end system. The question is like, how would the system know between like, let's say me creating a tweet or Andrew creating a tweet? Like, would it be based on like the IP of the system it's on or like what? But what it would be is, usually you would have, some sort of login capability. Then when you log in, you'll make a request. You'll say like, hey, I want to log in. Then when you say, hey, I want to log in, it'll give you back an ID of a user that you just logged in as, assuming your login was successful. Then whenever you do anything in the app, you'll do it through the context of that user ID. Does that make sense?
Yeah, it makes perfect sense.
Okay, perfect. Any other questions? Yes. So like you wouldn't want someone to be able to create a tweet without being logged in, right? So you would say, hey, if you're not giving me an author, if you're not giving me an ID for this author, and you're not like verified to perform this action, like if you try and give me someone else's ID or like it's not a real ID, you're not going to be able to create a tweet, right? And we'll talk about some of that stuff with like authorization next in 2 weeks when we talk about Next.js. But that's a good question. It's up to the like implementation of the system. Okay. Any other questions about any of the reference stuff or anything we've gone over? Okay, sweet. So now that we've defined what our data should look like, let's use Mongoose to actually put some data in the database. Okay. So first thing we'll do is we'll create a user. I'm going to be working out of this lesson.ts file. In order to do this, we will create a function. So I'm going to go ahead and create a function called create user. Okay. And then, and then that should take in an argument. This function should take in an argument called user, and that type should be that user type that we already specified, right? Because if we look here, I want to say when you create a user, you need to give me your username, email, first name, and last name, right? I want to take a quick aside to talk about this word, this keyword here, async. Okay. We didn't talk about it when we talked about TypeScript a few weeks ago, but we need to know it for all this database stuff. So what this async keyword is saying is that the function is asynchronous, right? What does that mean? This function won't be able to just execute one line after the other, right? If we think about an example, so in a normal function, you have like 1 plus 1, and then you have 2 plus 2, right? And these are going to all happen pretty much immediately. So it's going to do 1 plus 1. Okay, good. Then it's going to do 2 plus 2. Okay, good. When we're talking to the database, that's not going to be the case, right? Because the database, we actually have to access the database over the internet. So if you've ever been to a website, you know that when you load a website, it takes a while to load, right? It doesn't just instantaneously load. The same thing happens when we try and access the database. It takes a while to load. It's got to, send out, hey, I want to connect to the database. It's got to do a bunch of stuff. Then it's going to come back and say, you're connected. So this means that we can't assume that I can't just have like connect to DB in here and assume that that's going to happen before this next line runs, right? We don't want to like block the whole function until that database call happens, right? We want to be able to keep doing other stuff. So we're marking this function as asynchronous, which means that it's going to run this line. Then maybe before that line finishes, we're going to run this line, right? And then when this line finishes, that's when we'll be able to return. But it's essentially just saying like, hey, we don't really need to wait. Like this is going to take some time. We might not want to wait for some of this stuff to happen. Does that make sense? Okay, cool. So to kind of backtrack inside of this function, the first thing we'll do is we'll call await db connect. And this db connect function is something you'll always have access to in a Hack for Impact repo. But you'll notice we also have this new keyword here called await. So that the await keyword here is the reason that we marked this function as async. You'll actually usually see these two concepts talked about together when you see like async await. You'll see like async await JavaScript or async await TypeScript. Await is essentially saying, hey, actually, I want you to wait for this to finish, for this call, this function to finish before you continue, right? So we don't actually need to because we have this async function here, but we want to. We want to make sure that this DB connect, like we want to make sure we connect to our DB before we actually try and interact with it, okay? Does anyone have any questions about that? That's kind of confusing and jumps into like a whole topic. Yeah.
Asynchronous function just gonna run no matter what. It's not gonna wait on anything, but when you put a wait in, it's gonna wait whatever that condition is on that line.
Exactly. It's gonna say don't continue. Like you can imagine after we connect to the database, I would do like, create a user. In the async function, if I don't await this function will run and it won't like TypeScript won't wait for it to finish, and then it'll try and create a user. But it's going to be like, hey, wait, I actually am not connected to the database. I don't know how to do that. So that's why we mark it as await, because we're saying, hey, wait for the database to connect. Then you can create a user. Okay. Does that make sense? Okay. So let's go ahead and actually create that user. To do this, we'll say return await user, and then this is going to be that model dot create user. And that's it. That's all the code we need in order to interact with our database and create a user. As a quick primer, the user model has a bunch of methods that you can use to interact with the database. So in this case, we're using this create function to say, hey, I want to create a new user in the database. Here's the data for you. Okay. And then we're awaiting this because, again, it's going to take some time for it to communicate to the database, say, put it in the database, and for the database to say, gotcha. So we're saying wait for that and then return the result of that. Okay. Any questions about anything we just went over? Async await, what's going on, anything? Okay. And that's it. Yeah. So let's actually call this function. I'll say create user, and then I'm going to pass in a new user for me. So we'll say username, zmoney. We'll say email, xavier@miller.com. I can supply, I'll actually go ahead and supply a first name, Xavier, and a last name, Miller. Okay. Then I'll go ahead and run this code. If you're following along, after you've written some code in lesson.ts, you can do npm run lesson. And it's going to run that. And it's actually not going to halt. So we can go ahead and look in our database. I'll click this refresh button here. And you see Mongoose has gone ahead and created a new collection for us. I don't know if I pointed it out earlier, but there was no users collection before we ran this code. Okay. Now we have this users collection. We should expect to see a document in here with the correct data. Yep. You see here, we have username zmoney, email xavier@miller.com, first name Xavier, last name Miller. So we've actually gone ahead and created some data in the database. Yeah, Mike.
So for this to work, did you already have to have MongoDB running, like when you executed the code? Could you like open MongoDB after executing it and see a new collection name?
So yes, so this Compass thing is different than like the MongoDB server. This Compass is like a user interface so that we can like interact with an already running server. When you're working on your projects, you will actually, we use like a hosted instance. So you'll have, I'm going to disconnect, the question was, did I need to have the database running in order for this to work? Forgot about that. But if I disconnect here, I have a bunch of database. Oh, I shouldn't have showed this. Oh no, it blocks it out. Okay, nice. I have a bunch of databases and I can actually like connect to this database, and that's hosted. And so like everyone can connect to this. And then your application knows it also wants to talk to the same database. So you'll always have a database running. It's just, if you want to run a local database, you'll have to run that separately. Does that answer your question? I kind of went into a bit of a tangent. Okay. So I'll go ahead and disconnect from this one and connect back to localhost. Okay. So yeah, so we have our user in the database, and that's beast mode, right? So now that we have a user, we can go ahead and create a tweet for this user. So we'll do the same thing here. I'll kind of go through this part quickly because the create tweet is essentially the exact same function here. Create tweet. Tweet is going to be I tweet. Then we're going to wait. We're going to connect to our database. Then we're going to return tweet.create tweet. And I'll go ahead and comment out this. I don't want to create another user in the database when I run this again. So I'll comment that out. And then, excuse me. And then now we can actually use this function to create our tweet. So let's go ahead and call create tweet. We'll create the text here. Super awesome stuff. And I'll save that. Oh, did I not go back? Oh, I actually forgot. So I found a bug. I forgot to update this I tweet here to say we also need an author. So that'll do that. And now, okay, this is what I was expecting earlier. I was expecting to get this error saying, hey, we're missing our author. So again, this needs to be an actual ID. This can't be just like my username. This needs to reference an actual user in the database. So in order to make this work, I'm going to come into the database and I'm just going to copy this object ID here. The important part is the part inside of this parentheses and single quotes. This is the actual string ID that we can use. So if I come in here and I say author and I paste that in, we have now pasted in the ID of my user. Okay, so I'll go ahead and run this again. And now again, we don't have a tweets collection, but since we used it, I can now refresh and you'll see we have the tweets collection. And inside of here, we have our tweet, super awesome stuff. And we can go ahead and make sure these match up. 66047. 66047. Awesome. So that works. Well, I guess we should look at the end. 0 EC. 0 EC. Sweet. So now this is actually referencing our user. Okay. So next, I actually want to go over getting some data from the database. Okay. But before we do that, I want to talk to you guys about a pattern that we use at Hack for Impact. Okay. You might have noticed on the left-hand side here, with our models folder, we also have this actions folder. And inside of this folder, we have an actions file for a tweet and for a user. Yeah. Okay. So in our actions folder, this is where we'll put all of the code that interacts with the database, right? So for example, this create user function will, I will cut that out of here. And I'll actually paste that into my user action file because we're interacting with the database. So we want to store all the code that is interacting with the database in this one file. So it's all nice. It's all together. And then we can just use that in our application. So I'm going to go ahead and do the same for the create tweet function. And I'll put that into the actions tweets. Oh, nope. And I'll add all missing imports. And then again, down here, now it doesn't know what create tweet is. So I'll go ahead and, well, no, did I forget to export that? I think I did. Yeah. I'll need to export it so that other files know about it. And then I'll need to do the same in here. And so I just wanted to briefly touch on that because that's something you'll see whenever you're writing code that interacts with the database, it'll go in this actions folder. Okay. All right. So the last thing again I want to show is how to get data from the database. And I want to show you two things with this. Okay. First, I'm going to show you just a super simple, let's say like get tweet function. And this is going to simply, we'll give it an ID of a tweet and it'll return us back that tweet in the database. Okay. So I'll say export async function get tweet, and then we'll have tweet ID as a string. And then in here, we'll do the same thing. We'll wait for the DB connect. Okay. And then we'll use another method on our tweet model called find. And I think we actually have a find by ID. So we'll actually use find by ID. Or actually, I'll just return await tweet.find by ID, tweet ID. Super simple. And if you're wondering how I know like all these functions, again, it's just doing it over and over. If you're wondering like what all can I do with a model, I would highly recommend checking out the Mongoose docs. So I'll just look up Mongoose and wow, their result is actually the code. I was expecting it to just be all animals. And then in here you have a whole bunch of stuff. The most important thing to know is this models, or well, the API model. This will show you all of the functions you can call. So as you can see right here, we have that find by ID. And that's perfect because that's what we want to do. So we will wait to get our tweet back after we give it an ID. And let's go ahead and test this out. I want to be in my lesson. So I'll say I'm going to create an async function called run, just so that I can use the await keyword because the get tweet function is asynchronous, right? So I'll say await get tweet. And then again, I'll go to MongoDB Compass and I'll grab this ID of this tweet and I'll pass that in. And I'll set that equal to a variable called tweet. And then I'll just console log that. Okay, so let's go ahead and run that. Hello, oh, I didn't call my run function. Make sure we call our run function, run that. Sweet. So you can see here the result. This looks exactly like how it looks in the database. We have the ID, then we have the text, then we have the author. But it's not really useful in my application to say, hey, here's the author's ID. I would much rather have author be an object that is the actual author that's stored in the database. And this is another place where Mongoose comes in clutch and makes it super easy to do some of this stuff where you're working with references to other collections in your database. They actually have, if I go back to the tweet action, they have this method that you can call after you do like a find by ID called populate. And then in here, I can say populate author. And so what this is saying is, hey, instead of giving me back an ID for the user that this author represents, I want you to actually go into that user collection, find the user, and then put that in for the author field instead of the ID, right? So if we run this code again, whoa. Okay, this is a bug you'll run into sometime. So I'll actually import user. And then I'm just going to call it. This is something we've run into a bunch of times. Don't worry about it. It'll be fixed in the code bases you work on. So if we run this now, you'll see that rather than just getting the ID of our author, we're actually getting the author document back. So now I could use this get tweet function to get my tweet. And then, in like my React front end, I could say display tweet.author.username. And that's how I could show who wrote the tweet alongside the tweet without having to make an extra database call. Pretty cool, right? Does that make sense? Anyone have any questions about populate or about find by? Okay. Okay, so there's one more kind of thing I want to go over with finding or getting data from the database, and that is this function called find. So we'll make a new function. Let's say we want to be able to, let's say we have a profile page, and on this profile page, I want to be able to see all the tweets that a specific user has posted. How can we do that? So we'll go ahead and create a function that's going to do that for us. So we'll do the same thing, export async function, get all tweets for user, and then we'll pass in a user ID. And then in here, again, we'll connect to our database, and then we'll actually want to use this, we'll do return and then await tweet, and we'll use this function called find. Now, find is great because it lets you specify parameters or filters for your search, right? So rather than finding all of the tweets in the database, I want to find just the ones where the author property matches the user ID that I passed in, right? So all we need to do that is say author should be user ID. And what that's saying is give me all tweets in the database where the author field is equal to the user ID. Okay. And maybe I should go ahead and make another tweet to exemplify that, but I won't. So now we'll do the same thing. We'll do await get tweets, get all tweets for user, and I'll paste in my user ID. In there. and then I will console log that. Actually, I will create another tweet. So I want to duplicate, and then we'll make this D and see if we can do that. Yeah. So now you can see we have two tweets in here. One's by me and one's by a different user. This user doesn't actually exist, but this just isn't me. So if I run this function again, we'll see that it returns me an array with only one element, and that element is the tweet that was posted by me. And again, we could do that same thing where we like say, hey, I want to populate that so that I can actually see the user. So we'll populate author. And that will actually do that for every single tweet that's returned. Okay. So just to quickly recap what this does, first, our function is going to be taking in a user ID as a string or a user ID. Then it's going to go ahead and connect to our database. Then it's going to use the tweet.find function, which takes in a parameter that says, hey, find me all the documents in this collection that have these properties set to these values. So that has, in this case, that has the author set to this user ID parameter, and then return that. Okay? Any questions about that or anything else we've gone over today? How's this all feel? Yeah, Andy.
So I guess it's kind of, in terms of the await function, would it not make sense to run await on like every line if you're trying to grab something? Does that make sense? Or
That is a great question. So the question is, why don't we just put await on every line? You only need await when you have an async function. So if we look here, well, that's a bad example, but like, for example, in this lesson here, this get all tweets for user was marked as async, right? So because of that, I know it's going to take some time to execute. So I actually want to wait for that to finish. Whereas if I just defined a function that's like console log, for example, that's not going to take time to execute. That's just going to instantly execute, and then you're good to go. So we don't need to wait for that to finish. We don't need to mark that as a wait. We could, we don't need to, because it's not actually asynchronous. It's not going to take time to complete. Does that make sense? Like why we don't just put it on every line? We do put it on every function call that is asynchronous, right? On any asynchronous function. So the DB connect function is asynchronous. The tweet.find is asynchronous. So we'll do it on all those. But if we just have a regular old function, we don't need to put the await keyword there. Does that make sense?
yeah.
Okay. Anyone else have any questions about literally anything? We went over so much today. Any questions about anything else we went over? How's this feeling for everybody? Okay, maybe after like a rewatch of the video, maybe. Yeah. 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 I feel it. Well, awesome. That's it. I know we went over a lot today. If you missed anything, definitely go back and watch the video because this stuff is super crucial for building useful applications. Thanks for coming. Next week, we'll go over how this database stuff actually works with React to create an actually useful application. Awesome. If there are no questions, y'all are free to go. Thanks for coming. I'll see you guys later.